Let's look at a word problem that applies finding least common multiple. So again, least common multiple is the smallest multiple numbers have in common. So we have Marla is making bracelets with different colored beads. The red beads come in packs of eight, and the purple beads come in packs of 3. Marla needs the same number of each color bead. What is the smallest number of packs of red beads that she will need to buy? What is the smallest number of packs of purple beads that she needs to buy? So we need the number of beads to be the same. Having trouble writing. Number of beads have to be equal to each other. So red beads has to be equal to the same number of purple beads. Now, again, if students don't know if they're supposed to find the least common multiple, they could start with drawing some pictures. Now, there are some clues here. Smallest number of packs. In the GCF problem we looked at, the question was asking us the largest number. In this case, we're looking for the smallest number. So that may be a clue that we're looking for the LCM. But if students aren't sure about that, they can just say, okay, here's my red beads. Here's my first pack. It has 8. If I get another pack of 8, that gives me 16. If I get another pack of 8, that gives me 24. Okay, and they could keep going like that, or they could then start with their purples and say, okay, I've got packs of 3. So that's 3, 6, 9, 12, 15, 18, 21, 24. Okay, so I've got 24 purple beads now, and I've got 24 red beads now. They didn't have to necessarily list out all the purples. They could have listed out the 8s and say, okay, well, if I had 2 packs, that's 16. 16 can't be divided by 3, so I can't get the right number of purple packs. But once they get to 3 packs of red and they say that's 24, can I get packs of 3 beads and get 24? Yeah, I could. I could get 1, 2, 3, 4, 5, 6, 7, 8. So they would get 8 packs of purple beads and 3 packs of red beads. 3. All right. Another way they could do it is to simply, that we kind of did list the multiples in a way. We've got 8, 16, 24. They could list the multiples. They could list it this way: 3, 6, 9, 12, 15, and so on up to 24. So they could list multiples. They could do prime factorization. Would that work in this case? I don't know. What are they finding the prime factorization of? 3 and 8. Well, 3 prime factorization is just 1 and 3. It's just 3. 8 prime factorization is 2, and that can be broken down to 2. So the prime factorization of 3 is 3, and the prime factorization of 8 is 2 times 2 times 2. That would tell us that the beads would be 24 beads. Answering the question, LCM in this case will tell us how many beads we need to have. And then they would need to work back and see how many packs that is. Or we could do the ladder method. We could say, okay, we have packs of 3, we have packs of 8. What's the least common multiple there? I can't divide them by anything. So I'm just going to do 3 times 8 is 24. 24 beads is what's needed, and then they would have to figure out how many packs that is. And that is a least common multiple word problem. Let me know if you have any questions.